binomial distribution. In this video we'll look at binomial distribution and the type of questions you will get on an IB exam. First, let's look at what we mean by binomial. To spot a binomial distribution question, the first thing you should note is that you will be told a number of trials. So n equals number of trials. Binomial means 2. So P is the probability of success. In a binomial distribution question, you will only have 2 probabilities, success and failure. P is a success, Q is a failure. So let's look at the sort of typical question you might be asked. You might be told that you roll a dice 15 times. So the number of trials n is equal to 15. And you might be told that the probability of a 6 is equal to 0.75. So that is your success. So your failure, Q, will be the probability of not 6. And that will be equal to 1 minus 0.75, which is 0.25. You might be asked, what is the probability that our random variable x is equal to 6? In other words, in the 15 trials, what is the probability that you roll 6 sixes? You could do that manually, and that is equal to 15 choose 6, P, which is 0.75, and you want it 6 times 0.25, and that would occur 9 times. But whenever you're given a distribution, especially a binomial distribution question, you use your GDC.
Pick an amount, for example, exactly 6 sixes. If a die is rolled 15 times, you use binomial PDF. So go to menu, open a calculator page, menu, statistics, distributions, A. So in this case, the number of trials was 15. The probability of success was 0.75. We want 6 of them. Okay, so the probability of getting exactly 6 sixes, if a die is rolled 15 times, with the probability of getting a 6 of 0.75, has a probability of 3%. No, 0.3%.
So the probability that x is equal to 6 is equal to 0.0034 to 3 significant figures. We might also be asked, what is the probability that our random variable x is equal to greater than or equal to 6? What that means is, what's the probability that we get 6 sixes or 7 sixes or 8 sixes or 9 sixes or 10 sixes all the way up to 15 sixes? So that's the probability that x equals 6 plus the probability that x equals 7 plus all the way up to the probability that x equals 15. Again, we can do it on a GDC.
Of getting 6 or more sixes when a dice is rolled 15 times, you use binomial CDF. So menu, calculator page, menu, statistics, distributions, B. So our number of trials is 15. Our success was 0.75. Our lower bound, we want 6 or more, so that is 6. Our upper bound is 15. Okay. So the probability of getting 6 or more sixes if a dice is rolled 15 times with a success rate of 0.75 is 99.9%.
So in this case, the probability that x is greater than or equal to 6 is equal to 99.9% to 3 significant figures. We might also be expected to find the expected value of x. And that's just another way of saying the mean. So we might be asked to find if the dice is rolled 200 times, how many sixes would we expect? And the expected value is equal to the number of trials times the probability. So another way, in this case, we would expect to get 200 times 0.75, which is 150 sixes. So if this dice, which is heavily biased, was rolled 200 times, we would expect to get 150 sixes. We may also be asked what would the variance be if it was rolled 200 times. And the variance of x is NPQ, which in this case, if it was rolled 200 times, the variance would be 200 times 0.75 times 0.25, which is equal to 37.5. A typical IB exam question will be as follows. A six-sided biased die is weighted in such a way that the probability of obtaining a 6 is 7/10. Part A. The die is tossed 5 times. Find the probability of obtaining at most 3 sixes. This is a binomial distribution where our variable x belongs to a binomial distribution with the number of trials 5 and the probability of its success, which in this case is obtaining a 6, of 0.7. In part A, we want to find the probability of obtaining at most 3 sixes. So we want the probability that x at most, so that's less than or equal to 3. So that is the probability that x is equal to 0 plus the probability that x is equal to 1 plus the probability that x is equal to 2 plus the probability that x is equal to 3. This will be done on a GDC where the binomial, because it is between two values, binomial CDF with n equals 5, p equals 0.7, lower bound is equal to 0 and upper bound is equal to 3. And when you put that into your calculator, you get the probability that x is less than or equal to 3 is equal to 0.472 to 3 significant figures. Part B. The die is tossed 5 times. Find the probability of obtaining the third 6 on the 5th toss. To answer this question, you split it up into 2 distinct parts. The first part is that you are going to roll the dice 4 times and you want exactly 2 6s. Then you multiply that answer by 0.7 because you know for sure that the 5th toss is going to give you a 6. So the first part, if you do it on your GDC, 2 6s out of 4 rolls gives you an answer of probability of 0.2646. Then you multiply it by 0.7 because you are certain you're going to get a 6 on the 5th roll. So that gives you a probability of 0.185, which is equal to 18.5%.